Hi everyone, welcome to the next video on functions and relations. So today we're going to have a look at chapter 6.4 on the rectangular hyperbola and the truncus. So the first one is we're going to have a look at the graph y equals 1 over x, and we call that a hyperbola. Before we do anything else, we'll just have a look at what happens. So we've got y equals 1 over x. Well, first thing we can say that we can't have x equals 0. Okay, if we had x equals 0, that point there we'd have 1 divided by 0, not defined. Okay, same thing for y. Okay, we can't have y equals 0 for the same reason. Okay, because it's not defined. Now before we go into graphing them, we're going to have a look at a table of values. So completing the table of values will kind of give us a feel for the graph. Okay, what does it do? So table of values, you've got x and y. Okay, and just a variety of different points. Okay, so the negative numbers at negative 10. Well, at negative 10, 1 over negative 10. So we'll have 1 over negative 1 over 10. At minus 4, our y value 1 over minus 4. Same thing for 2. And for 1, we'll get minus 1. Okay, 1 divided by minus 1. And for 1 over 2, okay, that's what we have. We can say that's 1 divided by a half, okay, making them into fractions, multiply and flip, so we'd have that, so that's equal minus 2. Okay, same thing for a quarter, we'll have minus 4, and when we get to 0, 1 over 0, not defined. Okay, so that's the negative numbers, and very similar for the positive numbers. So if we have positive a quarter, a half, 1, 2, 4, and 10. So at 1 quarter, we'll have positive 4, positive 2, positive 1, positive a half, positive a quarter, and positive a tenth. So what do we notice? So for the larger values of x, okay, these whole numbers here, we actually get a really small number the further we go along. And same thing over here, a very small number for our y values. In the middle here though, when we get to smaller numbers, so fractions and decimals, our y values become bigger and bigger. Okay, we obviously get a difference between the positives and negatives on either side as well. So when we go to graph it, okay, it's not defined at 0, so that's what we call an asymptote. Okay, so down the middle, we're going to have a dotted line indicating we've got an asymptote at x equals 0. Now asymptote means it's getting very close to it, never touches it though, and that's what these numbers here are indicating, these whole numbers. So the smaller we go in for x, the closer it is going to go to that asymptote. Key points on the graph though are these ones here. Okay, so at positive 1 we get positive 1 for the y, and same thing over here, at minus 1 we go down 1. Okay, so it goes through those 2 points there. Now, if I go a quarter, okay, so very small point there, we'll say, we actually go up to 4, which is all the way up here. Okay, and same thing for the negatives, goes all the way down here. Then, when I look at the point 4, or negative 4, we actually go all the way down here, but it only goes down a little bit. And same thing on this side, when we go across to 4, it only goes up a slight amount. Okay, now connecting the dots, okay, I could put all the other points in, just to save time. It's going to go like this. Okay, and very similar on this side. Going through that point 1, and it gets close. So as you can see, the closer we go to 0, the steeper it goes up, and the steeper it goes down. And along the horizontal axes, we also get the similar effect. So we actually end up having 2 asymptotes. Okay, so I can actually draw in one here, indicating that we have y equals 0 as one asymptote. So I've got 2 asymptotes. Okay, one at x equals 0, one at y equals 0. So closer we get to 0, the steeper it goes. So that's a graph of 1 on x. Fairly straightforward until we get dilations and translations. So I'll go through an example of one of those in the next video. So stick around.